Cool. So safety first presentation I've given a few times. This is the most extensive one I've done so far. So see how that goes. Hoping for the best. So hi, my name is Simon.
Hi, Simon.
Takes a bit of time usually. So I work at SilverStripe as a software engineer and security expert. The team I usually work with is the Ninja Unicorns. I've created multiple multi-factor authentication systems in SilverStripe. I have a cat and I have a mascot. That's Hans. I have a zoo on my desk, as you can see. Lots of plushies. And according to others, I am scarily obsessed with security. I'm somewhat bribable with whiskey, beer, or Lego if you really want to. And I collect stickers from all kinds of conferences. So if you're interested in some weird sticker, I might have some for you. So what are we going to talk about today? Why safety first? Think before you do. There are hardly ever software developers, software engineers that start their project with, I want to make sure there's a backdoor in my program. Even writers of malicious software like viruses do not want backdoors in their programs. So think before you do and use the tools that are available. And we're going to mainly focus on the tools today and how that impacts your life. But there's always one big factor in writing software, and expect a data breach. People will always find something. It's often, I've heard it quite a few times, like, but my site is so small, why do people care? Well, you prepare for the worst. It can only be better than what you've prepared for, usually. And most best practices are, in absolutely no particular order besides the last one, people. Mistakes are made by people. A common example of that is Tesla. Recently, their autopilot for their cars did not recognize African Americans. Why? They did not have somebody like that on their team, and they completely forgot about it. Their whole team was white, and they didn't think about black people. And I'm not blaming Tesla. I am honestly pretty sure that there's absolutely no malicious intent there, but those things happen. And preparing is better than having to fix a big massive hole in hindsight and be stuck with it. So it happens on all levels, from the engineers that write the software to the people maintaining the servers to clients and users, but the common denominator, people. On that, I'll go like this, or should I go? Right, so my clicker stopped working. Nice timing. Battery's probably dead. Who here has heard of Taylor Hornby? This is the description of his website. This is Diffuse Security, which is a company he runs, and he's a well-known security expert. And we learn how to make systems more secure and then write software for it. What I'm trying to prove here is not that Taylor Hornby is an idiot, because he's a genius, but this is a tweet sent out by Taylor on the 13th of May 2016, for those that can't read it in the back. And he made a challenge. Convince me to put the term backdoor POC Twitter into one of my software projects. It so happens that his website, he hosts it on GitHub. So our friend Steve here said, you should put this challenge on your website. This security expert asking to be tricked into putting something into one of his GitHub repositories. It took half an hour before the term backdoor POC Twitter was in one of his GitHub repositories. This is a security expert expecting to be phished, wanting to be socially engineered, and it only took half an hour. People are quite a tricky factor. So, what can you do is what we're going to talk about, and obviously there's a lot of stuff we can't cover. There's a lot of stuff you can't do as an engineer or a manager or whatever your role in the project is. In the end, you can only do your best. But we can be aware of what's happening. When working with clients or managers, what can we do? A great example is this comic from Monkey User, especially for software engineers. They are very recognizable and humorous. It's where the business logic basically breaks everything around it, where a client or requirements basically break security, APIs, speed, usability, etc. So let's start with how to make sure your own projects are safe. This is a very developer perspective. The first one is PHP. It's one of the most used languages on the web, so I figured I'd start with that. Also, it's the language I work with professionally the most. There's the team, Roave team. I hope I pronounce it correctly. And they have a security advisories repository that contains all known vulnerable projects in the PHP ecosystem. By adding simply this security advisory to your own projects, you will prevent known vulnerabilities to come out into your project. And this happens every once in a while that I'm running a composer update, as that is nowadays the default for PHP, and it updates the Roave security advisories, and it just goes, nah, I don't want to update anymore. I'm just going to quit. Vulnerabilities happen all the time, and this is for PHP one of the good ways to prevent it on your own system. A more wider tool that I also use is Snyk. This is a free and paid for service which you can include for your open source repositories. It's free, and it monitors basically the same as what Roave does just for your local project. This is an online service that can help you solve Node problems, JavaScript problems, .NET, Scala, Ruby, PHP, Python, Golang, and they've recently introduced even a scan for that's in alpha mode, a scan for raw JavaScript, just pure JavaScript. They scan for known attack vectors and will report on it for you. Especially in open source projects, it's free. Why not use it? Is a very good advice on that one. And on that regards, there's also GitHub. GitHub doesn't support much languages yet, but it has support for known JavaScript libraries. It doesn't have PHP, it does have Node.js libraries. GitHub will send for all your open source and closed source repositories an email once a week saying, hey, these vulnerabilities are found. Even recently, there was a vulnerability in Bootstrap. Who knows Bootstrap, the CSS framework? There was a vulnerability in the CSS framework of Bootstrap, and I got a notification from GitHub saying, hey, one of your repositories uses an old version of Bootstrap. you'd better update because there's a leak in CSS, which is quite. I don't know who or what they did to the CSS, but I was quite intrigued that they managed to do it. Moving on from how to protect your own code, there's also how to protect your clients or your colleagues, your friends, password managers. I've probably, how many people here use a password manager? Let's start with that. About half, that's not bad. My first and foremost advice when it comes to password managers, often it is a very old security measurement to not allow pasting in password fields. Where would that come from? Anyone has an idea where that originates from? The idea of not allowing copy pasting of passwords. It comes from Windows 95, where the clipboard was publicly accessible. So this is literally more than 20 years, almost 25 years ago, that there was a vulnerability in Windows 9. Who here uses Windows 95? Thank you. In Windows 95, there was that's as far as back as I can trace it, a vulnerability where the clipboard was publicly accessible. So when you copy pasted something, the browser had access to it no matter what. So it could be read with JavaScript. This was in the Internet Explorer 6 time, where there was also ActiveX, that had access to your entire clipboard. That's where the advice of don't copy paste passwords come from. Nowadays, browsers are sandboxed. This vulnerability doesn't exist anymore, yet it persists. People keep saying you should not paste passwords. Copy pasting passwords blocks password managers from doing what they should do. Even if you use a password manager, you end up with, what is it, 20? 100 characters password, because it's in the password manager. What does it matter? And then you suddenly have to type it. I feel very sorry for everybody that has to do that. And I have been quite upset about that as well a few times. So copy pasting passwords is not bad. It's actually a good thing because it helps the usage of either browser built-in password managers or third-party password managers like Bitwarden, which is my favorite. I honestly am not being paid to say this. I wish I was. I like Bitwarden because it's open source. 1Password is one that is often recommended by people like Troy Hunt and John Optenacker. And LastPass has its biggest commercial usability around password managers. Try when clients come to you with strange password requirements, like we want to disable password managers, try to explain where it comes from. I see I've mixed up the order of my slides slightly, so we'll go to HTTPS quickly for now. What can you do with a non-HTTPS or actually an HTTP site? You can inject a Bitcoin miner. A hotel might do that. And it's actually not just, that's not just uncommon, it actually happens all the time. The only exception I have for a site that should use HTTP instead of HTTPS is the site httpforever.com. This site is run by John Optenacker and it's purposefully HTTP. The reason for this is that you've probably all been to an airport or a hotel or even the supermarket, where when you try to use the Wi-Fi, you get this login screen for the Wi-Fi. This login screen is literally intercepting your actual browser's communication with a secure site and redirects you to that portal. In that process, it can capture your cookies, it can hijack your session, and by hijacking your session, it has access to your Gmail because you visited Gmail in your browser. And this may sound like it's not that scary or not that big a deal, but an often nice comparison a friend of mine recently made was, who doesn't lock their door when they leave? Nobody. Good. You still lock your door. Even if you didn't have a PlayStation, a TV, an Xbox, 2 spare laptops, and another phone in your house, but just your house is entirely empty, who would still lock their door? I'm guessing most people, hopefully. Even if you think I have nothing to hide, you still lock your door. So that's why you should go and only use portals on an HTTP safe site. HTTPforever.com is a site designed to support this. So the portals can hijack that. You have nothing to lose because that site doesn't do anything. After that, you can go back to your Gmail because then the connection is properly encrypted again. And it's really easy to implement HTTPS. It's often said by especially companies like GoDaddy. Symantec Secure used to do it until they were phased out. Get yourself a certificate from us because it's safer. It's not. All a certificate does is make sure that the communication between the server and the browser is encrypted and that nobody can sniff it, that nobody can read it. Let's Encrypt. I am a big fan of them. It's free and it's really easy to set up for server managers, and even you need very basic knowledge of how to set up a server to get Let's Encrypt running. It updates itself, it keeps itself up to date. So there's no reason to skip that. And yes, your simple HTTP site with only a bit of text does need encryption nowadays. On the topic of extended validation, what a lot of certificate companies offer, extended validation is, what they basically do is they verify you own the website, which is what Let's Encrypt and all other free services do. And they also verify that you own the business. It takes me a day to register a business. In New Zealand, I am born Dutch, so in the Netherlands it was even half an hour. It's just one phone call and an online form, and I had my business name registered. It has no value to add the extended validation because all it does, especially with modern browsers, basically removing and only showing yes, it's encrypted or no, it's not encrypted. The added value of it is entirely gone. I put a link under there from Troy Hunt where he explains extended validation is pointless. As I said, especially with Let's Encrypt. Let's Encrypt gives you an automated system that updates your certificates for free, and your certificates are valid for only maximum 90 days, meaning that if they get hijacked, the impact is somewhat limited. After 90 days, the certificate is renewed, so the hijacker doesn't have access anymore. A simple thing to do, but really pretty tricky to implement, is register as HSTS. HSTS systems tell browsers that a website may only be visited via HTTPS. An HSTS registered site is literally put into your browser. Each new build of the browser contains a full list of sites that it should never ever attempt to access over HTTP. Browser just simply won't do that anymore. An often heard reasoning is, why am I using HTTPS on my whole site? Well, for the same reason that it needs to be on a static site or a simple site, even if it doesn't contain a form. The traffic between the server and the browser is still readable by an attacker. And it's a very real thing. We have clients that are unsure about this. I know this is a bit developer oriented, so I'm talking about clients in this case. I'm linking Troy Hunt's demo where he shows what he can do with a non-HTTPS website, which varies from injecting Bitcoin miners to injecting unicorns to... It's a half-an-hour video of everything he can do with a non-HTTPS site. And here's the difference. This is a Chinese hotel. And this is a Chinese advertisement on the exact same site. On the left, we have HTTP, and the hotel just injects advertisements into the website. This is a Chinese hotel, but they might as well inject a Bitcoin miner. And if that happens, especially on a phone, your battery will drain really fast and your phone will get really, really hot because it just drains all resources to a Bitcoin miner. Simply implementing HTTPS prevents all this worry of third parties trying to do something inside your browser. This is always my favorite intermezzo, where I show it keeps looking away, and it's how it still goes. Always keeps me entertained, and it's always nice getting a drink of water. So back to passwords. Like I said, I've messed up my order a bit. Apologies for that. I have a very simple rule. For myself, I actually follow the rule 100 characters or more whenever possible. I recently tried to register with Trustpilot, and I tried to register with 100 character passwords, and all I got back was, whoops. I had no idea what to look for. It was whoops. Bit of trial and error turned out to be 32 characters was their limit. It's slightly acceptable. It's more than 16. And my rule is basically any password under 16 characters is bad. And I know banks have this habit. Financial institutions have this habit. All you can do about it is pressure them. Tell your bank, hey, this is bad practice. And there's also often the rules around which characters you can use. Literally, emojis is fine. And yes, it works. If the setup of the website is correct, emojis work just fine. Spaces, fine. Anything that is within the Unicode set of characters is fine, because if it's properly implemented, in the end, it's all just a hash string. And that's just a set of characters that the database can save. It doesn't matter what the actual input is. And on password rules, there's always a great example. In this case, it is a Troy Hunt with my favorite airline, KLM, which is the Royal Dutch Consumer Air. And their reasoning for their new portal was to stay ahead of changing security standards. They are introducing a new robust password format. This password format was a minimum of 6 characters, must contain a capital and a special character. In other words, password with capital and a 0 instead of an O was an accepted password. Funnily enough, I've traveled with KLM a few times, and I decided to update my portal password. My 100 password of only lowercase characters, 100 lowercase characters, was rejected because it was unsafe. Computers don't care that much about complexity. Computers care about entropy, the length. The more characters, the harder it is. And Troy here obviously points out that mathematical complexity is a human factor, whereas for computers, length is the factor that matters. Okay, I admit I said my only real rule for passwords was a minimum of 16 characters. Not entirely true. My friend Troy Hunt, he's not my friend, I only met him once, but he also set up the service Have I Been Pwned? Who has heard of it? Awesome. I don't have to explain much. All you can do here is block passwords in your applications that are known to be breached. GitHub does this. If you reuse a password that is known in Have I Been Pwned, GitHub will immediately lock your account, send you a notification email, and force you to change your password. Sign up for notifications from Have I Been Pwned, so you know that when your email address appears in a breach, you get a notification. The recent MyHeritage hack, I got 5 on all of my email addresses. I'm glad they were all disabled by now, so I hope there was no password in there, and all those passwords I've never used ever again. But it's good to be notified. It's annoying. It's like, oh, not again. At least you get notified. And this Have I Been Pwned has its own service, as well as Mozilla Firefox Monitor, which is more friendly and integrates with Firefox to give you, it will basically prevent if you integrate it, it will prevent you from using the password in a website. Firefox will just go, no, this password is known to be breached, even before you try. Don't reuse your passwords. I hope I don't have to explain that. The moment you reuse it, for every reuse, the chances of your account getting breached increases exponentially. And don't expire password. This is a very common thing. Every 90 days or something, you get a notification. You should reset your password. There is no need to reset a password unless there is a valid concern, unless it is expected that the password has been breached because your service has been breached. There's no need to reset the password. Resetting passwords every 90 days plays on the human psyche, causing for, I'll just add a 1 at the end, and after 90 days I'll replace the 1 with a 2, with a 3, with a 4, and it's basically the same password all over and over. Rainbow tables generated to crack passwords know this practice, and once they see it in a certain pattern, all of them, and they just can see it. A great example of this is not reusing passwords but being so obviously in the wrong is a quite major banking company in Europe had their main server in 2015, password protected, of course. Their password in May 2015 was spring 2015. But they has a password rotation policy. So after 3 months, May, June, July, 1st of August, password needed to be changed. Can anyone guess? Summer 2015. 3 months later, yes. And then 3 months later, winter 2016, because it was a new year and it didn't violate the no reuse of passwords. Yet the pattern was so obvious that they got in quite some trouble with a security testing company, thankfully, and not actually being hacked before everything went wrong. So don't expire passwords. It only creates security issues, because the system administrator was like, I have to change again, and went with, I'll just go with whatever. It works for me. So don't expire unless you're really, really sure that there's something wrong. And another big thing, multi-factor authentication, the thing consumers hate. But it's better than nothing. Something you know and something you have. Having to check your phone, needing access to your phone, or needing to have your security key before you can get access does massively improve security. I didn't manage to include it in here, but it literally, an Australian company last week lost 26 of their AWS servers due to a disgruntled employee. One employee managed to get the credentials of their ex-colleague, go into the AWS dashboard, and trash 23 of their servers. Into the millions of costs. Not 100% sure if it was Australian, I'm fairly sure it was. But a setup of two-factor would have prevented this, because that disgruntled employee also needed to have access to the phone or keys of their ex-colleague. And that's a lot harder than happening to find the password. It adds security to your account. It does not prevent password leaks, sadly. If your database or sticky notes, whatever, are breached with all the passwords in it, it's still breached, but nobody has access to your service yet. There's that second layer. And yes, somebody actually tried to sue Apple over multi-factor authentication taking too long. Which, yes, I agree, is a facepalm. It takes too much effort. Yeah. So with multi-factor authentication, the most common used is text message. Avoid if possible. Because text messages are interceptable. Phone hijacking is the actual thing where your phone number is being hijacked. It's regularly in the news for multiple reasons. So I admit it's better than nothing. But if possible, please use something more robust, most commonly TOTP, which is the Google Authenticator, Microsoft Authenticator, and Authy apps. These codes are only 30 seconds valid. They are still phishable or interceptable with a very smart system that represents the website you're actually trying to log into, but at least it's limited to 30 seconds. It's better than, the only better way is U2F, which stands for Universal Second Factor, which uses a certificate on a key. I happen to have a bunch of them. These kind of keys, security keys. This key has a certificate, and the browser can read the certificate, check it with the server if this certificate is valid, and then comes back. This is not hijackable or phishable because it is limited to the scope of the website. So when I log in with my key to gmail.com, if I happen to be on inbox.gmail.com, sadly they're closing down inbox, my key doesn't work. I need to register it separately again. It is strictly limited to a very confined scope. So there's no no way of phishing it. Because if I go to my fake website.gmail.com, the browser will go no, because the certificates don't match. So it is the future, U2F, in my opinion. Not everybody will agree that it's nice to carry around the key, but it's the safest way of carrying around a second factor. And to protect your own website, a more complex topic on that is content security policies. It tells the browser which external resources it can load. When I go to a website, when I go to stuff.co.nz, and Stuff has a proper security policy in place, it will tell the browser, yes, it is fine to load Google Analytics, but it is not fine to load Google Analytics, because that's obviously a fake domain. If somehow Google Analytics is attempted to be loaded, the browser will go no. That's where content security policies are meant for. They block everything that you, as the developer, has not explicitly allowed. And on top of that, there's a way to track these violations. It's a really cool tool made by Scott Helm. It's free for up to 10,000 records, and it will give you a nice view of, hey, in this case, this is one of my sites I maintain, and tiny.cloud tried to load their favicon, and it is reported as this is not allowed because my policy doesn't match up. I get a nice report and I can see, okay, which domains did I miss? Can have a look and improve it. Or my development team can have a look at it. This is my personal site, so I have to do it. A development team can have a look at it. And it comes with fancy graphs to show you how much has happened in violations over the last couple of days or weeks. Most of the time, these are browser extensions trying to load something into your website. I'm pretty sure it's roughly 95% that these are browser extensions trying to load JavaScript onto my site, which I obviously don't allow because they're not my JavaScripts, they're not approved by me. Which shows that, roughly 100 on a normal day, it's between 90 and 100 of violations of pure browser extensions. And on top of that, there's SubResource Integrity. This is basically validating as a developer and client. The browser will validate if the code that is being loaded actually matches what it is expected to be. Basically, adding a JavaScript with a validation code. What the browser will do is it will take the actual JavaScript, check if the code is the same as the validation code given, which is the SRI, SubResource Integrity, and it will only run if it is valid. If it's not valid, the whole JavaScript is just blocked and the whole site will break down. And if the remote site in that case, for example, Google Analytics gets compromised and the Google Analytics code gets injected with something malicious, it will just be rejected. Because the developer has validated this is the code that is allowed to run. And suddenly there's a different Google Analytics script. The browser will just not even attempt to it, preventing possible malicious code injection. That's pretty much me. If you're interested in what I do all day, follow me on Twitter at Firesphere. Tryhunt, Scott Helm, John Upton-Acker, DiffuseSec. Those are some awesome security folks on the internet. SilverStripe is where I work. The Roave team is one of the ones I often use. and is Monkey user for the wonderful relatable comics. If you want to get in touch, I believe there's an OWASP Slack. Is it still active?
InfoSec NZ Slack.
There's InfoSec, yes. I didn't want to advertise that because Sparkle Ops asked me not to.
Okay.
So that's by invite only. Meetup.com, obviously, and if you're interested in SilverStripe, there's a SilverStripe Slack. That was me. Any questions? Lots of silence.
I have a question. That's not as a developer, but more as a user of websites. You know, you've mentioned several times the typical hotel website with the HTTP page where you've got to sign in. But what a user, you know, a customer of the hotel, there's nothing you can do against that. So would you recommend you to close all your other tabs, clear your cookies before you?
No, because browsers, all the tabs are isolated.
Yeah.
My advice would be open a new tab before connecting to the Wi-Fi. Open a new tab, then connect to the Wi-Fi, and then in that new tab, open the httpforever.com website. That tab does not have access to other tabs. So it's those are all separated. So it's not like your entire browser is captured. It's just that one website that you initially visit. So HTTP forever in a blank tab separates everything from the rest, and there's no hijacking possible there then.
With the SubResource Integrity, do you have a recommended library or plugin for that?
It's not really. It's SHA-256 and then base 64 encoded.
Okay,
technically,
cool.
it's wrapping a library around it is a bit overkill. Yeah. Cool.
Okay. Well, thank you very much.
Thank you very
Simon.
much.
Let's give him a.